And good morning to all the participants. I welcome you on this very important session on the use of basically space technology in governance. Today, we'll have some idea how this particular technology, what we are discussing during since last 4 or 5 days, we will see especially this technology where we are using in the governance and in our day-to-day life. So now I will bring you from space to Earth, and here we'll be talking about a technology called geospatial technology. And if you see a brief introduction about this technology, it is an integration of three technologies. One is a global navigation satellite system, what we have seen during the session by Dr. Nilesh Desai ji from SAC Ahmedabad. He discussed about GNSS, where we have seen some of the typical example like global positioning system, GPS, Navik from India. So basically, this system is used by using this Earth orbiting satellite, which can provide the precise the location information on the Earth's surface. Either it is a static object or a dynamic object. So we use this technology to get the precise information about the object in Earth's surface. The second technology, what we discussed yesterday, was a remote sensing technology, where we discuss about the Earth observation system. We use the satellite or aircraft, and in fact, in this day, we also use the drone to capture the information about the Earth's surface. And after capturing this information, we correct these images with respect to height in the Earth, and then we convert this as a digital ortho image. And these digital ortho images are used to generate the maps of different themes. Like you can say, you can create the infrastructure layer like a road. You can create the settlement data or map. You can also create the agriculture map. You can create the forest map. You can also use these data sets for creating some disaster damage assessment or monitoring of any disaster or like a cyclone, flood, and so on. Then we have a third technology called geographic information system, which is a software system with capability of input, storage, manipulation, analysis, and output display of geographic information. And when we talk about the GIS, basically it is a basically integration of information and communication technology with geographical data. So GNSS and remote sensing are the source of input data for GIS, and GIS system provide for storing and manipulation of GNSS and remote sensing data. And when we see this geographic information system in our operational use, today you must be using many online mapping applications like Google Map, ISRO Bhuvan portal, where a lot of special data is available, and we are using these data set for our day-to-day life. Now, if you talk about GIS, what is the GIS? So GIS is basically, we use this terminology in three aspects, like as a system, as a science, or as a study. So when we talk about geographic information system, that means we are talking about the technology. So it's basically integration of multiple technology, what I've shown in last slide. But when we talk about the science, it is a concept and theory. When we study about the different concept and theoretical aspect in the Earth system, that time we talk about the geographical information science. When we use this particular technology with respect to societal context, that time we use as a geographical information studies. So societal point of view, we are using in many applications. Today I will be discussing few of these applications and how ISRO is supporting in the governance or for better governance by using this technology either from the space observation or GNSS or maybe by geospatial technology. And here, this particular technology, in nutshell, we can see that it is giving you information about place on the Earth's surface. It gives the knowledge about what is available and where and when it was available. So here, most important point is a time domain. So when we give this information, we give this information with respect to time. Suppose I'm giving some observation from the space for today, for example, for Dehradun. So I will say that I have captured this information from this particular sensor using the space sensor or maybe some aerial sensors on particular date and time. So when I have this kind of temporal representation with my data sets, so I can take the similar kind of same observation after some time, maybe after 1 month, maybe after 2 months, or after 1 year also. So when I take this kind of observation in time series domain, that time I can also visualize changes happening in the grounds. So that's why the time is very, very important point here, what we have to keep in mind. Now, if you see the different type of questions, what we can answer by using this technology is, first is we can answer the questions like location informations. We can ask the question, what is available at this particular location? So suppose you have a question, what is available at Delhi? What is available at X, Y location? So this kind of questions we can answer. Second is conditions. So question like where it is available. So where is it available? So for this also conditional statement also we can answer here. We can also answer like a trend analysis. During the last 100 years, how things are changing in a particular locations. During last 20 years, how things are changing in particular locations. This kind of trend analysis we can also perform using GIS. Next important questions what we can answer is the patterns. For example, if you want to understand the pattern of a temperature in a particular area, so you can also understand how the temperature is being recorded, how temperature is changing during the time. So in this way, we can understand the pattern of a particular phenomena in the geography. So this kind of queries we are able to answer using this technology, but most important aspect here, this particular technology allows us to do the modeling. So modeling means it is basically an abstract representation of the reality. So what we do, we convert the geographical information in a computer system, and then we basically analyze this data by using some mathematical aspect, and then we can also model the future scenarios. Suppose we have the location, for example, a city. Suppose I am trying to understand the city growth in a particular area. So suppose I want to model it. What is the condition after 30 years? What is the condition after 50 years? So this kind of modeling exercise we can perform here. So most popular modeling exercise what the scientists or researchers do here is basically like a land use or land cover modeling. So suppose in a particular area, we are utilizing a land for some purpose. And if we want to understand how this land will be utilized after some time, for this kind of modeling, there are a lot of research or activities are going on. So we will be discussing some part of these things in coming slide also. Now, if you see the knowledge base of GIS, what is available here, we are talking about three important subjects here. One is a computer science, second is geography, and third is a application domain. So in terms of computer science, we use this particular science for the graphics, for visualizations, for database management system, for administrations, for security of the data. In the geography, because since we are talking about the geographical data, so here we have to have some understanding about the cartography, we have to have understanding about the geodesy, photogrammetry, landform, spatial statistics, and in the application domain. So where we can use it, we can use in many thematic domains like public administrations, for planning, for geology, mineral explorations, forestry, site selection, marketing, civil engineering, criminal justice. So here these days the criminal GIS is also available. Like you can also do this kind of mapping, so where more crimes are happening. So it is very, very useful for the police department to basically identify the areas which can be a threat for a particular society. So we are using the survey technique and so on. So these are not a limited things here, what I'm displaying here. So these applications can be many more applications we cannot list here in one slide. So as per your requirement, you can use this technology for your own domain. Now, what type of geoinformation services or systems are available these days? As for today's environments, basically we are working in two type of geographical information system. One is a desktop or simple computer-based system, and second is a network-based GIS application. If you talk about desktop-based systems, here the only single user can perform the activities here. So what you have to do, you have to identify a computer system, and then you have to install the software. You have to also install the data. Then you can start working on this system. But another thing which is very popular these days is called network-based GIS applications. You must be using Google Maps. So what is happening here? So you know that how much data Google is giving to the public, and from where this data is recorded, from this where this data is basically processed, and where this data is hosted, nobody knows it. But user is simply opening this thing in their browsers and then start using it. So this kind of GIS is getting very, very popular. And not only Google Maps, there are a number of such mapping applications available in internet. From ISRO side, we have a portal or web portal called Bhuvan, where we also host a large amount of data for Indian region, basically for developing the innovative applications at the user end. Today we will be seeing it. And the advantage of this particular technology or the network-based GIS system, it is a multi-user and second is a cross-platform. So advantage of this multi-user is the users or hundreds or thousands or millions of users can access this data or information at the same time. And another advantage is a cross-platform. So cross-platform means suppose you are using your internet in mobile, then also it will work. If you are using in a desktop, it will work. If you are using in Windows, in Mac PCs, your Android, iOS, any operating system. So here the advantage is a cross-platform. So here the specific softwares are not required. So here what type of data we handle here? So in this kind of technology or geospatial technology, you have two type of data. One is called attribute data, which basically gives you the characteristics of a geographical features. And second is called spatial data. So here I will give you the example. Suppose you are capturing an image of a particular city like Delhi, Hyderabad, or Chennai, or maybe Dehradun. By using the satellite observations, what you can do, you can definitely capture the footprint of a different geographical features. Like you can capture the footprint of a building, you can capture the footprint of the complete agricultural land, you can capture the different type of forest types, you can also capture the road, but you cannot tell, for example, the name of the road. You cannot tell from the space what is the name of this building. You cannot tell what is the use of this building. So, but this information is very much required to take appropriate use or to utilize this data better way or to make a better decision. Then these attributes are necessarily required. So these attributes generally we collect from the ground observations through ground survey. So for example, suppose you have captured a footprint of this building, but by seeing from space, I cannot tell either this building belongs to a school or it is a private building or it is a commercial building. I cannot tell this information. But if I attach the attribute from the grounds, and if I have the ground information, then I can attach the characteristics like this building belongs to a school. Then I have the complete information. In due course of time, maybe the use of this building may change, but that time again I have to update this information from the ground. For this purpose, we store the two type of data. One is called attribute data. Second data is called a spatial data. So when we do the spatial data, spatial means data related to location. So in this case also we have the two type of data models what we practice here. One data model is called raster data model and second data model is called vector data model. So what does it mean? So raster means it is a simple photograph what you are capturing through your mobile. You can see that when you are taking the photographs, you can see all the geographical feature nicely in these photographs. In fact, you can recognize the different features there depending on the resolution of your camera. Same thing is applicable in the satellite sensor also. But another data model which is called vector data model, where we store this footprint in the form of geometry, and these geometries are basically point, line, and polygon. These are only three geometry what we use to store this information into the computer system. But now important question is, if I can see everything in the raster image, if I can see everything in the satellite imagery, I can recognize by my eyes very easily, then why I have to convert this point, line, and polygon? So because the computer cannot understand each and every feature precisely. So what we have to do, we have to give this information to our computer system, because ultimately we are going to analyze this data by using the computer system. If I have the capability to automatically extract the features from the raster images by using computer algorithms, then definitely vector may not require there. But here as of today, so we use many algorithms, many classification technique. As yesterday also, Mrs. Meenakshi Kumar was telling about the digital classifications. So that time we have also using the machine learning, artificial intelligence. There are so many techniques still evolving, but the vector data is giving us a better opportunity to analyze or to use this data effectively. This is a typical example. We also use the concept of the layer. Layer means the thematic or the information about a particular theme will be storing into a single file. For example, suppose you are extracting the information about the road network, all the roads you are extracting. So that time we will say that it is a road layer. If I am extracting all the agricultural lands, so what I will say, it is a agricultural layer. If I am extracting all the forests, then I will say it is a forest layer. But typically, in case of satellite observations, we'll be seeing this kind of mixer. You can see here the building footprints. You can see the trees. You can see the grounds, playgrounds, and all. All the features are available in the single file. But if I start analyzing or extracting the information on the fly using the computer system, then I need a more computation capability in my computers. That's why generally we prefer to basically extract these information in the form of the layer so that we can utilize this data in better way. Now, when you are extracting this information, when you are storing this information to your computer system, you have to keep in mind three important things. I think these things are very common for all geography teachers. These are called projection, second is called scale, third is called accuracy, fourth is called resolution. So projection is basically a mathematical methods by using which we are converting three-dimensional data into two-dimensional data. You know that the Earth is a 3D, and when we are preparing a map for printing purpose, so generally we will convert these 3D to the 2D formats. So in this 3D to 2D conversions, we have to ensure that we should not lose any information here. So here the different type of projection systems are available. We use this projection system. Another important consideration is a scale. The scale is a ratio of the distance on a map to the equivalent distance on the ground. So this basically, since I told you, when we are taking the observation from the space or capturing the satellite imagery, so ultimately this data set or these imagery we have to store in the computer system. So when we store in the computer system, then we have to define the accuracy or the correctness of these data sets. So here, very important, the accuracy is how well does the database information match with the real world. Because whatever observation I'm taking, because this question was there, how this accuracy or how accurate these data sets are. So here we have the three type of accuracy what we study. Here the positional accuracy, we have the consistency, we have the completeness. So here the positional accuracy says how close are features to their real world location. So we have the basically here methods by using which we can tell the positional accuracy of a particular data set. Then we have the consistency, like do features characteristics in database match those in the real world? Is road in the database is a road in the real world? So sometimes suppose we are interpreting or we are extracting this information from the satellite imagery, the human also can do some mistakes here. So here the consistency is also very, very important. And another important consideration is the completeness. Suppose I am extracting the road network of a Dehradun city, the very important thing, until unless I am extracting all the roads in a database, then I cannot say that my data is complete. So suppose you are making a plan for the future roads. So how you can make a plan without having the complete data with us? So for this purpose, the completeness is very, very important. Fourth important point, what we discussed yesterday also called the resolution. The resolution is the size of the smallest features able to recognize. For example, in the raster, we have the four type of resolution. Yesterday, Dr. Rajkumar has explained about it. We have the spatial resolutions, we have the radiometric resolutions, we have the spectral resolutions, we have the temporal resolution. So four type of resolutions basically we use to basically to define or qualify a satellite imagery for their accuracy. So this is a typical outcomes, basically after taking the observation from the space, then creating the digital elevation models, then how we can generate a realistic image of a Earth surface. This is a real animation of the Char Dham region in Uttarakhand. You can see the Gangotri Glacier nicely. It is not a movie or animation, simple animation created in the Photoshop or anywhere. It is an actual satellite observation taken there. If you see the height of the mountains, when we capture this height, we use the two sensors in our satellite. For this purpose, here the Cartosat 1 satellite is used, and then you can see the nicely the 3D visualization of this region is created. So when we do this kind of 3D visualization, when we create this kind of animations, then here we can also do the measurements. So measurements, two type of measurements we do. One is a horizontal distance, vertical distance. We can also create the area, so like the valleys, and we can also analyze. Suppose there is a waters, we can do the volume estimation of the water also. So this is a simple animation for Kedarnath temple. You can see here, and the hill area is shown in this particular visualization. So this image is captured by using our Cartosat 2 satellite, and 3D observation is using the Cartosat 1. So two satellite data is basically integrated together, and a beautiful fly-through of a Himalayan region is prepared here. So now you can see this is a Satopan glaciers. After that, we will reach to the Badrinath, where you can see the Badrinath temple and all. So this kind of visualization basically you can perform or you can generate by using this technology. Now, how this information flow works here in this particular domain. So here you have to understand, one is the data. Data is the simple observations what we are doing either through the space-based observation or ground-based observations. When we process this data, then we can say that now we are having the information. So data, if you process this data, it will become the information. If you include the model here, and this model could be any mathematical model or any other type of theoretical model also, then we will be developing a decision support system. Or sometime, if this decision support system is for the spatial data, then we call it a spatial decision support system. But in the later stage, we also use the advanced computation technologies like artificial intelligence, machine learning, and deep learning kind of concept. In that case, we can develop an expert system. So what is the difference here? So data can give me the information. Information means whatever is available in the data, I'm just processing and presenting to the users. But model is creating scenarios for the futures. But knowledge discovery here is the final decision by the computer system itself. But in case of decision support system, whatever scenarios are being presented, the final decision will be taken by the decision maker or a human being. But here, what is happening today, the faster hardwares are available and distributed computing systems are available, and most of the data, most of the software system are available as open system architectures. And today, the mobile devices and wireless communication network is becoming a very, very important tool for the users, and where we are able to handle the large data repositories. The terabyte and petabyte of data is being received by this space-based sensor by using the ground-based sensors, and the large data repositories are available in the server farms. And by using advanced GIS softwares, we can do this kind of analysis or future scenario generation kind of things. So here, the advanced computing systems are helping us. And here you have to understand, so whatever developments are happening in the computations, so the same developments are directly influencing the GIS also. So whatever you see the advancement with IT, so same advancement straightway will be utilized in the geographic information system also. So if you take the example of the mobiles today, so we are using mobile for many applications, like for our day-to-day activities, for social media, for the getting the news. We are watching the TV now in the mobiles. At the same time now, geographic information system or satellite data or satellite-based observations are also available in the mobile applications. So these things are growing parallelly, and we are developing system indigenously at ISRO also, and we also use the data from other space agencies to solve a specific problem. Now, if you see, we have seen it, the integration of the remote sensing, GNSS, and the other techniques. We are basically building a geospatial technology. But here, another important point, what I would like to mention here, is the integration of ground data. Ground data is very, very important here. And this ground data, right now, people are using or collecting by different methods. One method is very popular, called as a sensor network. So we have launched many satellites. There are hundreds of thousands of satellites in the orbit. The same way, and these satellites are having the sensors. And through this sensor, we are receiving the data into Earth station. But at the same time, we also can set up the sensor network in the ground also. For example, automatic weather station. You must have heard about Doppler radars. There are pollution sensors. There are traffic sensors. So people are now installing the small sensor in the ground. And when we receive this sensor data either through the satellite network or through the internet or some other network. So then this data will become a part of my geospatial data server. Another important source of data is a crowdsourcing or participatory GIS. Today you see the social media. Social media is playing a very, very important role. Basically in the governance also we have seen if something is discussed in social media very seriously, so government has to take call on that. The same way, the scientists and researchers also utilize the social media data for effective decision making and planning activities. So for this purpose, today, if you take the space-based infrastructures, this is from India, from ISRO, from the 360 meter to around 27 centimeter resolution data we can capture from our space sensors. So here, and you cannot say that if I have the data on high resolution like a 27 centimeters, then there is no use of coarse resolution data. It is not like that. It depends on the different applications. Which data is suitable for which applications? By studying the requirement, the expert will decide on that part. There are certain standards are available, which data I can use for which application. But what you have to understand here, when you do the observation in the high resolutions, like this 27 centimeter from Karnatak 3, then your SWAT, or SWAT is basically how much area you are covering in a one scan, will be very, very limited. But when you are taking the observation like a AVIF sensors where you have around 800 square kilometer swath, but in case of Karnatak 3 you may have around 15 kilometer swath. So that what does it mean? Suppose I am taking the high resolution, that means I can only scan the 15 square kilometer in one shot. And you have to understand, these remote sensing or these satellites are not giving you data continuously. The continuous observations are not there. Basically what happens, we open the satellite sensor around 9:30 to 10:30 time period in morning. That time, whatever things we are seeing from space, we'll capture and we'll store the data into the server. Same way it is happening for other sensor also. But some of the sensor we do the day and night observation also. But in general, the high resolution satellite basically will capture the image on a certain time. So then if you see the different Indian Earth observation programs, we have the different type of satellite for different applications like land and water. We have the resource satellite. For high resolution satellite, we have the RISAT and Cartosat. For ocean observations, we have the Saral Arctica kind or maybe OCM series of satellite. For weather and climate, we have a Megatropic inside 3D or Kalpana 1 inside 3DR. And these satellites are available, and we have the good space infrastructure today available in India for variety of applications. Now, if you try to understand the spatial versus temporal resolutions, what is the use of it? Now, if you see the high temporal resolutions, large swath, what does it mean? Temporal resolution means after how many days I can take the observation for the same areas. Suppose I'm taking the global coverage. This is a very, very coarse resolution with respect to spatial resolution. But here the large area I can scan at a time. Slowly, if I go to the medium temporal resolution, the large swath or big area will be there. But here the coarse spatial resolution for the regional level information. For example, suppose you are doing the national level assessment, then we will generally be using our AVIF sensor around 50 meters spatial resolution. So here we'll have the large swath so that we can cover entire India in very less time, so that we'll have the full coverage of our region of interest. Similarly, if you come down like a state level planning, so where we need a maps of like 1:50,000 scale kind of things, then we use the medium spatial resolution for local level information. So here we have the limited swath. So very small area we can scale here. But again here, the low temporal resolution means suppose I am taking the observation today for a certain area, and maybe I'll be taking the next observation after 20 days. In case of high temporal means I can take the observations every day, or maybe sometimes suppose you are placing your satellite. Suppose we are placing our satellite in a geostationary orbit and we are trying to observe the sensors Earth observation from this geostationary orbit. Maybe we can take the observation every half an hour also. So this way it will go, and it depends on the what kind of application you are building, and you can choose the satellite sensor. Now take the example here, the satellite and UAV image. This side, this is a satellite image from the a very high resolution satellite, and this image from the UAV or maybe drone-based observations. So you can see we are able to see almost all the features here, but in case of UAV observations, we have a better quality. But you have to understand, UAV can scan very limited area in a particular time. Suppose you start scanning entire globe or entire India by using the UAV, you may take a lot of time. But by using the space-based satellite, so you can scan in a very less time. This is another example where we can see the coarse resolution means image will be blurred, and high resolution means the geographical features will be visible in better way, and I can identify the more features here. So this is a very typical example where you can understand when we say that is a high resolution means more features. Coarse resolution means less features. So more image is blurred. So depending on the requirement, generally we choose this satellite image. This is a much better quality image. So here, so fine resolution data. Suppose you are taking a data like 1 meter or 60 centimeter resolutions. So better features are captured here. So I can create the better maps here. It depends on the applications. For example, suppose you are creating a map or data for the a city level plan. So you may require like a 1 meter resolution. And suppose you are making a plan at the ward level, or maybe a colony level plan or village level plan. So you may require the much more better quality data, or maybe where you are making the house level planning or street level planning, it depends. So here, now if you talk about the governance, where we are using this data in India. So why so many satellites in orbit? Why ISRO is spending so much money for launching the satellites? Now you'll understand what are these applications where the government is using this data. And being a technologist, a scientist, we are supporting the governance. We are basically providing the data. We are providing the technical support. We are also training their manpower, their human resources to develop these applications. Now, if you talk about, I will start from few ministry. I will tell you, Ministry of Rural Development. They are using this technology for the groundwater prospect mapping. I'll be showing you now in the coming slide the groundwater prospect map of entire India are available in the open public domain. Now, somebody can ask us how this groundwater is captured by the space-based observation. So basically, you have to understand it is not only the space-based observation. We use the ground data, we use the geospatial technology for this kind of mapping. So here, the modeling exercise is being done to identify the zones where the good or less groundwater is available. Then we have the wasteland mapping and monitoring. This project ISRO is executing since last 30 years. So we every 5 years interval, we provide this information to government, the status of the wasteland in the country. Of course, we use here the different seasonal data. In a year, at least 3 cropping season, we use this data, and then we identify the areas which are wasteland. And further, government can use this information for planning or for setting up industry or to utilizing this wasteland for any purpose. Then we have the National Urban Information System. We have the AMRIT program from Ministry of Urban Development. We have the Smart City programs. So in these programs, a very important flagship program of Government of India, where these data sets are used. If you take the example of AMRIT, how this AMRIT program or Smart City programs, these satellite imageries, these geospatial data are used. So here you have to understand, one is a space-based observation. Through the high resolution satellite imagery, we can capture the images of the city and we can make a beautiful plan. And same time, by using the sensor network in the smart city, you must be hearing that a lot of sensors are being installed here. In the sensor network, the data from the ground will be coming to the server, and some data from the space, then integrate together and build a plan. Effective plan can be built here. Then in case of Ministry of Water Resources, we are using for irrigation infrastructure, command area monitoring, sedimentation of reservoirs, India Water Resource Information System, snow melt runoff, glacier lake monitoring, river configuration, flood forecasting, water source assessment, and so on. So there are a number of projects available or are being executed by Ministry of Water Resources where these satellite-based observations are being used. In case of Ministry of Agriculture, they are using this data for crop acreage and production estimations under the program called FASL. We use for agriculture drought monitoring, horticulture applications. In case of Ministry of Home Affairs, MHA, where they are using this data for space-based input for disaster management support. I'll be discussing more about this program in coming slide, because I have seen there were many questions in the chat box during the last programs, how in disaster management the space-based observations are being used, that we'll be discussing today. Then we have a national database for emergency management. This project, with the help of Department of Space and MHA, it is being executed, and ISRO has set up a data center in Hyderabad, near Hyderabad, a place called Sadnagar, where we have a huge data centers for national data. We call it the national database for emergency management, and then we use this for the flood monitoring, drought, landslide, and so on. In case of forests, or Ministry of Environment and Climate Change, they are one of the oldest user of space technology. They use this data for forest cover mapping. You may be knowing that the Forest Survey of India is publishing every second year the forest cover map of India, and they are effectively using this space-based data from these three sensors of resource set 2 and 3, and then biodiversity characterizations, wetland mapping, and so on. Ministry of Mines is using for exploration of minerals, and then there are many specific information requirement of like a Ministry of External Affairs and so on. Some of the popular applications I have listed here. We will start from agriculture. Now, as I told you, the agriculture, we are doing the area and production estimation of 8 major crops, and this information is required by the government for effective planning of this of a food grains. In case of in-season multiple forecast, we do satellite data plus agrometeorological plus land-based observation, and this is available as a operational service from Ministry of Agriculture. And here the Department of Space and ISRO is basically providing full technical support to the ministry, and they are generating a beautiful information on regular basis and providing this information to ministry to the government. Next important application is a potential fishery zone, or we call it the PFZ forecast. This is a very, very interesting application. Currently, it is operated by Ministry of Earth Sciences. And what ISRO has done here, we basically developed the methodology to identify the areas or basically zones where there is a chance of good fish catch on daily basis. And these alerts are basically disseminated to the fishermen of this coastal region of the country. And every day, we have a center called INCOIS in Hyderabad. They basically publish these alerts to the fishermen so that they can identify the areas where they will have a good chance of fish catch on daily basis. And here, basically what we do, we record the chlorophyll contents in the sea surface, and based on this, we do the modeling activities and identify the zone where there is a good chance of fish catch. And this kind of exercise has reduced the search time of a fisherman by 60%, and it saved the fuel cost by around 30%. It's a huge saving, and in fact, this is an assessment done by an international body and not by ISRO. So it is a very, very popular program and operationally available to the fishermen of this coastal region through Ministry of Earth Sciences. In ISRO, what we do, we basically do the R&D, we develop the methodology, we develop the space infrastructure, sensors, and then we hand over this technology to the concerned department for their operations use. Now, next important project is called monitoring of irrigation infrastructure. Now, this is a very, very important activities where we develop basically inventory and mapping of irrigation infrastructure. So like a canal building, how the canals are being built and what is the status of the canals. Suppose government is funding some money from the center or state level, then you can do the regular monitoring. Either this infrastructure is being really constructed in the ground or not. Although I am showing only example of irrigation infrastructure, but the same thing you can do, or same monitoring you can do for any kind of infrastructure development program. For example, suppose you are constructing the road network in the country, and in the ministry level, they can monitor the complete progress of the projects, how it is growing, because we can capture the satellite imagery on certain time periods. So we can overlay two satellite imagery together, and then we can see the changes happening in the ground, either the construction is being done properly or not. So then we have the very interesting program under the Ministry of Rural Development called Groundwater Prospect Zone and Recharge Site. And this is one of the very, very successful program from Department of Space, where we improve the success rate of bore wells and improve the water levels. So here, although right now the data sets are available on 1:50,000 scale, but ISRO is also working to improve the scale and accuracy of these maps. But currently, if you look for the 1:50,000 scale map for entire country, are freely available from our website plus the website of the ministry. So these groundwater prospect zones are available, but we are not saying that by using this map, you straight will go there and start digging the well. It is not the case like that. You have to use this data for the further geotechnical survey, and it will help you basically to identify these areas where you can dig the bores and you can take the water for drinking purpose. Then another important program of Government of India is called Watershed Development Program. Very, very popular programs. So here what we do here through the space-based observations, we use the space data or remote sensing data for better productivity potential and improved livelihood. Here for the soil and water conservations, we use for enhanced crop yield, decrease in the fallow lands. And this program is very popular and very active programs. Here ISRO has provided not only the data, we also have provided various mobile apps and web-based software application to the ministry so that effectively they can use this data for their day-to-day activity. The another important activity what ISRO is executing is called natural resource census. You may be knowing about this program, but in general, you see the normal the census of India. What we do every 10 years we execute it. But at the same time, what ISRO is doing every 5 years, we also do the census of our natural resources. In this case, we have identified around 7 themes, like we are generating the information about the land use, for the wetlands, for soil, snow and glacier, geomorphology, land degradation, and vegetation. And this information, in general, every 5 years, we update it. But some of the like geological structures, we basically update on once in a 15 years, which are not basically frequently changing. So these data sets are available from our website. You can look for this data, and you can also look for changes happening in these classes. Very nicely in our website called Bhuvan. Maybe in evening time, my colleague Mr. Kamal will be doing some experiment on that, how you can download this data, how you can use this data to understand the different pattern, different themes in your local areas. Now, if you come to the forestry, as I told you, they are using this data for the assessment of forest cover on 2-year cycle. They use this data for plant conservation measures, rapid forest mapping to the identify hotspot areas. Here, the Forest Survey of India is a nodal agency, and under this activity, basically, they use the resource set 2 and resource set 3 data currently, and every second year they publish this information. And you can download this forest cover map of entire India from their website. The same information is also published in our website also. Snow and glaciers, we are monitoring of the glaciers and snow cover areas. Very, very important activities. Here the glacier retreat, snow melt runoff forecasting, input the climate change. One is a scientific input. Second is, suppose you are understand the water level in the rivers, how it is changing and how much water will be available for drinking purpose, for agriculture purpose, irrigation purpose, and so on. But this is monitoring of the glacier are very, very important. And in fact, the monitoring of the glacier with respect to the disasters are also very, very important. So here we continuously monitor in some of our projects, and we also provide this information to the hilly states in India so that they can further use this data for their effective planning. In the urban area, already I discussed about it, we have successfully completed a program called National Urban Information System, where we have created 1:10,000 scale map of around 150 towns in the country. And after success of this program, government has given the next task to map or to generate similar kind of data for another 400 towns under the Amrut program. It is under progress. And then under the decentralized planning at the panchayat level, the geospatial data is used for the different activities like asset mapping. You may be knowing that in the Manrega program of Government of India, which is very, very popular for rural employment, here we have mapped all the assets under the Manrega programs through our geospatial technology, where the ISRO has provided the solution through the mobile apps. We have given the mobile app to the junior engineers and surveyor in the ground, and these things are mapped. And today, more than 5 crore assets are already mapped and are available in our own website. So there are so many applications where this technology is used. And when we are doing this kind of mapping and monitoring or creating the inventory of different assets, it is very, very important for government basically to identify many basically overlap with a different flagship program. For example, suppose you are developing some well or some activities or creating some or building some something like some road or some infrastructure. But what is happening if this kind of monitoring is not happening, then the same activity is being shown by different programs. So what we can do, we can overlay this data together and we can identify. And another important areas, already we have a very nice lecture on this, weather and climate. Dr. Pistowalji and from Dr. Mitra from IMD, they have discussed about it. You can see here there is a very good scope where these data sets are very effectively utilized, and better weather forecasts and alerts and advisories are generated for the society. Now I will introduce you with a very important initiative by ISRO called Bhuvan. This is a website. Name is basically URL is shown here. I request all of you to visit this website. So what we are trying to do, we are basically trying to build a national repository of satellite data plus the different maps in our data center. And Bhuvan is an initiative of ISRO basically for Indian Earth observation data for governmental planning, researchers, general public for the information. And we provide this information in 2D and 3D environment, so where you can do the lot of measurements, you can calculate the different like area calculations, distance measurement, and so on. And we are trying to build it is a indigenous system as an open system architecture. So sometimes people say that the Google map is having good satellite imagery. What about Indian system? So this is the Indian system where we provide a lot of data, a lot of information from the space, and in the evening time you will be seeing the live demonstration of it, how this data is basically utilized in the different government system. These are a different component of Bhuvan. We provide the geo-visualizations, thematic applications. We provide the free data download facility, G-governance dashboard. Here, more than 150 government projects. You can see how they are using these data sets. We have the mapping services, OGC services like Open Geospatial Consortium. So these mapping services are very interesting services, especially for the geography teachers. You can focus here. You can teach your student how to do the mapping, how to identify the geographical feature on the satellite imagery, and these activities without having any GIS software, any image processing software in your desktop. Straight away, the student come here, they can understand this concept, they can learn the process. In fact, some professionals also can use this for making the accurate map of their own locality. We have a ISRO disaster management support program. We call it ISRO DMSP. Here we address the 6 natural disasters, and this is available under disaster services. State portals for different states of India, climate environments, crowdsourcing, ocean services. These are the major components. This is a typical satellite image, what I have taken for this Rajpath area in our Delhi. You can see all the geographical feature very nicely here. And from the Bhuvan, this is a 3-dimensional view of the Simla area. Any part of country, you can capture this kind of 3D view. It is not only for visualization, you can do the measurements also. This is our website. You can see here in Bhuvan. I hope in evening time you will be seeing it. But I request you, if you want to understand the use of these data set in the governance, the bottom I have shown one URL. You just visit this URL. Here you will be seeing there are more than 150 such projects where this data is effectively utilized or being utilized by the different user community in the country. This is a typical example of the urban growth. Now, this is a very important thing. Suppose you want to understand from 1991 to 2021, how a particular city is growing. So these data sets are available under the urban growth monitoring. I'm just giving you an example here. So this kind of visualization on the fly in internet environment, you can do it. So this complete process is happening in background. We are basically building the satellite, launching the satellite, receiving the data, processing this data. Then we are basically publishing this information in an internet domain for public use. This is a website where you can get the groundwater prospective information. Right now, as I told you, it's available for entire India on 1:50,000 scale. And currently our team is working to improve the accuracy of this data, maybe 1:10,000 scale. The better quality maps will be available in future for the public. So these are the link from where you can download these maps for your own region. This is a very important component, especially for the teachers. I thought I should introduce it. It's called School Bhuvan. maybe if you are from the CBSE and teaching geography, you must be seeing in your geography book, now the school Bhuvan is introduced as by the NCRT, and we put a lot of effort there. We basically supported NCRT to build the contents, to make available this particular component to the student. And what you can do here, this is a portal providing map-based learning to bring awareness among the student about the country's natural resources, environment, and their role in sustainable development. So if you access the school Bhuvan, this is URL here. There are many things, many tools are provided, and especially for the student of class 9, 10, 11, and 12. So based on the structure designed by NCRT, what ISRO has done, we developed a system and we digitize all the maps, whatever you are teaching in the geography classes, and these all the maps are available in the school Bhuvan, and you can teach practically to your student so that they will have a better understanding. For example, what is the advantage for this? Suppose what is happening, suppose you are basically overlaying the annual rainfall map of India here. So when you are zooming on a particular area or maybe zooming to your own school, then you can understand, or the student can understand, what is the rainfall pattern for his or her school. So this kind of local information can be integrated. So this is just a simple, like a map, some experiment we have given here. So please explore it. I hope it will be useful for you. Another initiative for the teachers, what we have taken from ISRO is basically we are discussing with the NCRT very closely. And what we have done, we have created e-learning contents, especially for the geography, class 11th and 12th. There are chapters on the remote sensing and GIS, and whatever is written in these chapters are basically available as a fun or as a game for the student. And these contents we have posted into this website called elearning.iirs.gov.in. There is a section called NCRT courses. You can see here NCRT courses. Here you just click on this and see how we have built these contents. Basically, our idea is, when we are developing this content, we are keeping the student or children in mind, and in simple language, we are trying to explain them what is the remote sensing processes, how it is happening, how electromagnetic radiations are basically captured, and when we are capturing these basically observations, then how we are converting this observation to the information, like the spectral signatures, and extracting the information about the different geographical features. In the simple language are explained, and these contents are freely available for everyone. I request all the teachers, please look into this and try to understand. And if you have more requirement, you can write us. We can again look into this. If there is some more thing can be done, based on your feedback, it can be further improved. Now, if you talk about another important initiative from the ISRO, we have a center called Meteorological and Oceanography Satellite Data Archival Center. This is basically under Space Application Center, Ahmedabad. So what we are doing, as you know that we have the different weather satellite like INSAT 3D, INSAT 3DR, and these all satellite data in real-time mode, in near real-time mode, we are making available to the users through this website. In fact, we are not a meteorological agency. We are not giving any weather forecasts or any alerts, because for this IMD is a nodal center in India. What ISRO do? We basically do these observations, we capture these images, or we capture this information, make available in our data center. Anybody, any general public can log into the portal and can download every 15 minutes lot of data like cloud covers, wind profile, you have the cloud fractions, temperature, all this information is basically being captured and published here. Please visit this website also, and so that try to utilize, try to understand how these observations are being done. This is another important initiative what ISRO is doing on Indian Bioresource Information Network, or we call it IBIN. So this is a very, very interesting program. Basically, with the help of Department of Biotechnology, what we are doing, we are trying to map different plant like a flora and fauna species in the country. And all this digital data we have made available in this website called IBIN. And here ISRO is only giving the space-based observation, plus we are also integrating data from other bioresource data centers. Like we have around 15 to 16 data centers in India, and they have provided this data. We have geocoded this data and make available in the maps. I will give you a very simple example here. Suppose you want to look for a medicinal plant called Sanjeevani, where it is available in India. so you can get the geolocation of this Sanjeevani plant. So these are the such a small thing I'm telling you. But here, similarly, if you want to look for some birds or maybe some other species, that also you can monitor. And there are beautiful map and chemical data sets. What is the use of the plant? Suppose you are searching for a plant, a common name, so local name. If you are typing there, then it will tell you what is the use of this plant. So these all details are combined together, and still we are developing this repository. So please visit this website. So it will be very, very interesting for the student community also, so that they can understand the flora and fauna of the country in a better way, and they can also see their spatial representation on the map. This is another initiative of ISRO. We call it the visualization of Earth observation data and archival system. This is little scientific outcomes, especially for the science teacher. It may be interesting things. This website link is given here, vedas.sec.gov.in. So what we do, it provides a platform for utilization of information derived over land using mainly Indian spaceborne sensors to develop custom crafted geospatial applications which can feed into a support the decision-making system. So here the scientific data on the like a vegetations, or maybe we have the crop, or you can also monitor some development infrastructure and all. So all these data sets are available in this website, and we also publish some process data of the moon and the Mars, our programs, interplanetary programs under here. So this is a very, very interesting platform for the student community, especially for 11th and 12th students. They can log in there, they can start exploring this data, they can start understanding. And we also provide a lot of guidance to the student under this program. And here it's completely free, of course, things are available. So please explore, please start visiting this website so that you'll have the better understanding what is available there. This is another example on the Amrut programs. As I told you, in the under the government flagship program, we are providing support to the government. But this is a basically initiative by our own center here in Dehradun. What we are trying to do, the ground information, how they can collect through the mobile app, and directly they can link with the observation taken from the space as a spatial data. So basically the attribute and spatial data, how you can connect together, and using the simple mobile device. So now you can use this mobile app to collect this ground truthing, and then you can link these attributes automatically with the geographical features recorded by the space-based sensors. Then if you come to the disaster management, I have just kept few slides because yesterday I was seeing there are many questions on disaster management. Now that in disaster management, you have to understand here, we are not a disaster management agency, we are a space agency. What we are doing, we are providing support to the disaster management through our space-based infrastructures for the flood, cyclone, forest fire, landslide, earthquake, and drought. So what exactly we are doing, we will see one by one. In case of flood, what we are providing, we are doing the flood inundation mapping. If there is an alert of a heavy rainfall by IMD, so immediately what we do, we program our satellite, we capture the satellite imagery there, and the pre and during the flood, two images we compare together, and then we also calculate the damage assessment and all. But flood inundation mapping we generate, and we provide this information to the up to the district collector in the country, and we set up a network called ISRO Disaster Management Support Network, DMSP network, through the satellite-based connectivity, and these informations are provided. Cyclone, we'll be seeing in the coming slide how the Taute and this cyclones are being monitored from the space. And then forest fire, using the thermal sensor, we detect the forest fire location every day, and this information we basically provide to Forest Survey of India, and further they send this as a SMS to the DFO as a mobile SMS, so that they can take the appropriate decision. So day and night we do this observation of the forest fire. Landslide, two activities currently we are doing. One is we have identified the landslide zonation mapping we have done. So landslide zones are identified. Plus we also do the landslide early warning. Also we are generating as a R&D activity. In the earthquake, we have a very, very limited role to play being a space agency. Currently, what we are doing, we are using our satellite basically for the damage assessment after any earthquake. So currently, we do not provide any alerts or any advisory on the early detection of earthquake or forecast of earthquake, because I have seen many questions are there, but in earthquake we do only the the damage assessment after the earthquake. In drought, we have a continuous program. During the rainy season, we monitor very closely. Every 15 days, we generate the drought, meteorological drought basically, and this information. And currently, this is being executed by Ministry of Agriculture in their center called Crop Forecasting Center in Delhi. So they use the satellite data for this purpose also. We do the hazard zonation mapping, especially for flood and landslide, damage assessment, monitoring of major natural disasters. We also have a program on the R&D toward the early warning of disasters. We also provide the international support and capacity building and training to the planners and decision makers. So these are the major activities. Whatever I discuss is a flood. We do the flood inundation mapping, damage assessment, hazard zonation, bank erosion studies. In drought, monthly agriculture drought report, end of the season agriculture drought report, forest fire, active fire detections. Daily basis we are detecting it. We also do the burn area assessment as a damage assessment, earthquake, cyclone, and landslide. These are some examples which we have published. Is a multi-resolution satellite imagery and disaster-specific products. You can see from the Cartoset 1 list 4 data set. These are the example of the flood inundation mappings. Forest fire. These are the examples for burn area assessment. For the landslide damage assessment, also we are very closely monitoring, and these reports are sent to the ministry or concerned district collectors or district magistrate for their better decision making. These are some flood response products, the state level, district level, detailed flood maps, and this is not ad hoc based programs. We have a very dedicated programs here. We are having a decision support center in Hyderabad. On 24/7 basis, we run this center and we provide these alerts and advisory to the government. This is a mapping of the low-lying areas, especially in Hyderabad. I have shown example here. So methodology is developed by ISRO. We identify the areas where there is a chance of flood, where the flood can sustain for long durations, or these areas are identified so that it can be an alarm or alerts to the people. Those are basically doing the infrastructure development activities there. So these all the maps are available freely from our website. Near real-time monitoring of the cyclone. This is an example of Taukte, the cyclones last month on May 17 and 18. Very closely we monitor using our satellites, and every half an hour basically we update these informations. We basically monitor the intensity of the cyclone very closely, and basically we do not provide any advisory alerts. We just publish the track of the cyclone with the help of IMD. Basically IMD do the validation, and ultimately the IMD will generate the alerts and advisory to these citizens. So here in collaboration, both the department will work together and generate the alerts. This is a landslide hazard zonation. Again, already I explained about it. This is one example. Maybe you may be knowing about a very serious disaster happened in the February 2021 in the Chamoli district of Uttarakhand, where there was a flash flood due to this rock slide and avalanche area due to this avalanche. So what we do, basically we activate the international charters and we capture the satellite imagery from the satellites, and then quickly identify the areas where this basically disaster was originated, and then quickly we do the damage assessment. All this information was provided to the government within few hours of this disaster. These are the typical examples here from our NRSC website. All these informations are available, so you can see the damage by this flash flood and pre and post disasters. Both the images are shown here, so you can see the pre-disaster, what was the condition in this area. After disaster, this is the conditions. So very easily any layman also can see the damage in this imagery. This is the example of the fire, forest fire. You know that I was talking about the forest fire alerts as a point location we are giving, but this image will show you how we are able to capture. In fact, on daily basis, you can do this kind of observations. The forest fire in Uttarakhand. This is a April 4, 2021 image, and then 3D fly-through of this area. So you can see here the smoke in this valley, how it is basically trapped. So you can see the active fire in this. These are the orange areas, the points. I hope you are able to see it. These are the active fire locations. Each and every fire you can identify in this image. You can also identify the areas which are basically burned by this fire. Very easily we can see, we can identify how much damage is there in the forest. Very nice fly-through or 3D image of that region is captured, and it's very useful basically for the forest department to understand the damage and to mobilize their field staff to take the appropriate action in the ground. So this kind of things also we develop. This is for 2019. Similar kind of things, little better quality. So you can very nicely see here the forest fire lines are visible in this image. This is another initiative by ISRO called National Database for Emergency Management. As I told you, we have a data center in Satnagar. We provide the cloud movement. We provide the Intermeteorological Department rainfall data, CWC water levels, the Central Water Commission data sets, and current news, social media information also we capture automatically through our computation system, and we integrate with the satellite-based observation provide to the client. This is another R&D activity, basically for early detection of the forest fire in Uttarakhand. We are doing some modeling activity using geospatial technology. So this we develop one technique here, at least 24 hours in advance. We are trying to detect the areas where there is a possibility of forest fire in next 24 hours, so that the forest department can take early action or keep watch on this sensitive zone, so that the early detection of forest fire is possible for the planners and the forest managers. We also discussed with various departments, central government ministries. Currently around 160 space project in 2015 we identified. This project, this basically initiative was chaired by Honorable Prime Minister, and where all the ministries, about 60 ministries and the central government, they agree that this technology can be utilized for better governance in their own domain. We are providing the support to the ministry in many activities for planning and monitoring of the public benefit scheme of development projects. You can see here, since time is very less now, so I have to close because but here I've just listed. I will try to save these slides under the study material so that you can refer in the future also. With this, I thank you for basically joining this session. If you have any question, please post it. I will try to take few questions after 2 minutes. So by this time, I hope my colleague must have collected few questions for discussion. So with this, I thank you and close my session here. Thank you.